particle kinematics. We're going to draw a velocity time graph and use our TI-Nspire to answer all the questions. So you can imagine what this looks like. It's going to be a quadratic, right, with a negative t squared, so it's going to be concave down, right? We want the acceleration. We'll think about acceleration as rate of change of velocity, right? So we need the dy by dx tool. The times when the particle comes to rest, well, if the particle is at rest, its velocity equals 0, so we're going to find the zeros. The maximum velocity and the acceleration at this point, think about that. The displacement after 3 seconds, remember displacement is area under the velocity time graph. Total distance travelled is the area under the speed time graph. Total distance travelled, so that's still the speed time graph. And finally displacement, so we're back to the velocity time graph. Okay, so we need to be able to switch between each of those concepts. So let's get into it. To type this in and also to set the actual domain, we've got a cheeky little tool. Let's go doc, insert a graph. Now, of course, we're not going to use the t variable because we have to use x, so x minus 1, x minus 3. Now, you could go ahead and put that in, but we want to actually restrict the domain. So let's go and tell the calculator control equals, this is the given that. We use a symbol in probability as well. Given that 0 is less than or equal to x, control equals, opens a menu, is less than or equal to 3.5. Now let's go ahead and zoom in on a nice scale, right? So you can double click on the numbers here, -5 maybe, or you can go through the full menu, Windows zoom, Windows settings, right? So x min -1, let's go x max at 4, let's go y min at -5, why not, y max at 4. That looks okay, right? You can hover over this, and if you press the center button of your touchpad, your hand will just close and you can move this away. So we've got all of the tools ready, we've got the graph ready. We just need to go to the menu. Let's go and find out what it wants us to do. It wants us to calculate the acceleration. So acceleration is the rate of change. So menu, analyze graph, can you see? dy by dx, delta y by delta x, change in y, change in x. This is called the derivative. And literally you can see that the gradient's changing all the way along there, right? So the greatest acceleration is here, but the acceleration is reducing. So if you think about it, if the acceleration is reducing, it means the velocity is not getting as fast, right? At some stage, the actual gradient is going to be 0, okay? So let's just go and grab that and move it around a bit. Now we want a specific point when t equals 1, which is here, right, I think, and when t equals 3. But rather than kind of guessing, we can menu, analyze graph, dy by dx. You can literally just type in 1 with your keyboard, and there it is. So the actual acceleration when t equals 1, the acceleration is 2 meters per second squared. 2 meters per second squared. Let's do that again. Menu, analyze graph, dy by dx, and now we want 3. And here the gradient is -2. Now that's correct, right? There should be a symmetry to this quadratic function. And so we've got a +2 gradient here, 2 meters per second, and we've got -2 meters per second, so negative acceleration, right? So the velocity is at a maximum here, then the velocity is decreasing. The velocity is 0 here, then the velocity is negative. Now don't forget, velocity negative means the particle is traveling in the other direction. Okay, so you think about drawing a graph of this, kind of a linear graph. At some stage the velocity is very big, but in a negative direction. So it's moving kind of away from a starting point, and then it moves further and further away. At this particular point here, velocity is 0, so now it's turning back. Now it's turning back, it's turning back, it's turning back. Then the velocity is 0, and then it's moving away again. Okay, so that's the visual that you need. Let's go back to the questions. B, the times when the particle comes to rest. Well, you can even see from the actual equation, t equals 1 and t equals 3 are the zeros. C, the maximum velocity and the acceleration at this point. So maximum velocity, menu, analyze the graph, maximum. Click, click, and that makes sense that the zeros are here at t equals 1 and t equals 3, and the symmetry with t equals 2, the maximum velocity equals 1. Now the gradient at this particular point, can you see, is 0. There is 0 acceleration. Now that makes sense. If there's zero acceleration, the particle is neither speeding up nor slowing down, so it must have reached its maximum velocity. Maximum velocity 1 meters per second. Let's go back again. Okay, the displacement after 3 seconds. So displacement is the area under the velocity time graph. Menu, analyze, integral. And 0, enter, 3, enter. There we go. And can you see that? It looks like we've gone 2 seconds, and there we've done the first second here, then the next second here, and that is telling us that pretty much we think that the displacement is 0. This is 2.055 times 10 to the negative 14. Pretty sure that's very close to 0. So it's actually gone out a certain distance and it's come back the same distance. So that's after 3 seconds. The total distance, okay, now the total distance travelled after 3 seconds. Alright, so we go back to our graph. We're going to go double click on here, and now we want the absolute value. So abs, beautiful. Okay, so it's 2.6667. So it looks like this area here is identical to this area here. Now if you're wondering whether it was identical, you can go back and do the area from 0 to 1, then the area from 1 to 3. So there you go, that's the total distance travelled after 3 seconds. Let's go back to the question. The total distance travelled after 3.5, so we can go again, and we can go menu, analyze, integral. You can just type in 0, enter, 3.5, enter. Okay, we've got this extra little distance, and so that's a 2.958. So all of this distance here plus an extra, 0.3-ish, 2.958. And then let's go back to the question. The displacement after 3.5 seconds. So the displacement, we'll go back here, we're going to go back to the graph, and we're going to take off that absolute value. Now, this is a little bit harder because you might have to type in the function again. I am going to go and cut it, then I'm going to delete the absolute value sign, paste it back in, and there we go. Look at that, the displacement, this was from before, right, this little piece here, and this is now the displacement. So I'm negative 0.29, so basically I'm 0.29 meters, nearly back to the start again, or I've gone back to the start and come back the other way again. So there you go, hope that helps.